Is screen visible to you now?
Yes, sir.
Yeah. So we are starting with the mathematical foundation for artificial neural network. Okay, fine. Is the
Yes,
screen
sir.
visible properly? Okay. So mathematical building blocks for artificial neural networks. I'm just skipping a few slides which are not relevant, not actually not relevant, as we are not having much time. We are not explaining much about the unwanted things. I'm just going through the very essential things which are needed to understand artificial neural network. Okay? So usually we know the equation of a line, right? We always use the equations like y equal to mx plus c, right? Or ax plus by equal to z. These are all different representations of a line, right? So what is actually mean by equation of a line? What does that mean? If I tell you like c y equal to 3x plus 5 is an equation of a line, how will you understand that? Or can you just imagine how that line will be? Y equal to 3x plus 5? Or I can simply say like 3x plus 4y minus 7 is equal to 0. Can you tell me how you are actually interpreting this equation, and can you just imagine how the line will be? Or simply if I say, if this equation is representing this line, okay, this equation is representing this line, what you can actually understand from that? It's nothing but the line is actually composed of different, or it can be considered as a locus of different points, right? Locus of different points. And if you take any arbitrary point on this line, that is xi comma yi, okay, any arbitrary point xi comma yi from this line, if you substitute this xi yi on this equation, that equation must be satisfied. Okay, the equation must be satisfied. That is, definitely if you put the value of xi and yi on the equation 3xi plus 4yi minus 7, it should be always equal to 0. Okay, so from that understanding, can you tell me a single point or a point on this line? Any point on this line? Anyone? Any point which lies on this line? I said, if a point is lying on the line, then if you substitute that point on the equation of this line, then it should be satisfied. Then can you tell me one point on the line, that is 3x, which is represented by with the equation 3x plus 4y minus 7 equal to 0?
1 1.
Yeah, exactly. 1 1, right? 1 1 is a point. If you substitute this 1 1, it will be like 3 into 1 plus 4 into 1 minus 7 is equal to 0, right? That is 3 plus 4 minus 7 equal to 0. So we exactly know this 1 1 is a point on the line 3x plus 4y minus 7 is equal to 0. Okay, so hope you got the idea, right? And from this I just want to convey one more thing, that is, if the equation of a line is represented using this equation, that is ax plus by equal to 0, that is the constant part is 0 here. So is there any speciality for this line? Is there any speciality for this line? Ax plus by equal to 0, comparing to other lines which is represented using ax plus by plus c equal to 0. Is there any speciality for this line? Can you just imagine? See, I will show you that concept with a website. The website I'm showing is a very useful tool, which is called as Desmos. Okay, desmos.com. You can make use of it for the classes you are engaging. Desmos.com. So there is an option called open graphing calculator, and if you put this equation ax plus, okay, by plus c equal to 0, okay, and if you arbitrarily choosing some values for a, b and c, okay, you can actually find a line like this, right? You can actually find a line like this, and by changing the value of a, b, c, you can actually change the properties of the line. That is, you can move upward, downward, you can rotate, right? But what if I remove the term z from this equation? If there is no such c in the equation, what is the peculiarity? Whatever value you change for a and b, what is happening? The
It will
line
touch
should,
the origin.
yeah, the line should always pass through the center of the coordinate plane, right? So it is getting restricted that if there is no such term c, if there is no such term c in the equation of the line ax plus by equal to 0, then what will happen? The line will always getting restricted to move around the plane. It can only rotate according to the, or rotate over the center, right? Is the concept clear? Okay. And one more thing, that is, if we have this equation ax plus by equal to 0, and if you put some value for a, b, c, and then all the points, okay, all the points on this equation, on this line, should satisfy this equation, right? And this 1 1 1, okay, 1 1 1 is a point on the line, sorry, 1 1, so the coefficients are 1 1 1, and if you consider the values like minus zero point 0.5, minus zero point 0.5, then it will be satisfied, right? That is, see, if you consider this point, okay, this point, it can be minus zero point 0.5 and minus zero point 0.5. See, minus zero point 0.5 and minus zero point 0.5. The equation is getting satisfied, right? So every point on this line, if you move this cursor, you can see different points on this line. Every arbitrary point on this line, suppose if you take this point also, that point will get satisfied with this equation. Okay, it will get satisfied with this equation. Okay, now what about the points here, the above the line and below the line? What about the points above the line and the below the line? How we can represent all the points above this line, and how you can represent all the points below this line? Is there any idea? These things are represented using the inequality like this. See, if the equation ax plus by plus c equal to 0 is representing a line, then the inequality ax plus by plus c less than 0 is representing a region under the line ax plus by plus c is equal to 0. Is it clear? Right? So whatever point you consider from here, Okay, whatever point. If you consider this point, this will be what? Minus 6 0, right? This will be minus 4 0, this will be minus 2 0, this will be minus 6 2. Whatever point you consider at this region, and if you substitute in this inequality, it will get satisfied, right? And all the points above the line will get represented using the inequality ax plus by plus c greater than c 0. Are you getting the point? Are you getting the point properly? Yes? Okay.
Yes.
Yeah. Now we are moving into the next concept, that is, you know what is a vector and all, right? A vector is, if you consider a two-dimensional plane, okay, like we have explored in the previous example, two-dimensional plane, any point on that plane is having two coordinates, right? X, Y. So consider a line starting from the center of the coordinate plane directed towards that point xy, then that become a vector. Okay, then that become a vector. And in the same case, in the three-dimensional case also, see, there's a point 2 3 5 is a point, exactly a point. A vector starting from the zero towards this line, towards this point, is actually the vector 2 3 5. Okay, so this is exactly a point 2 3 5, and the vector 2 3 5 is a line that represents, or a direction vector that represents uh, a vector starting from the origin towards that point 2 3 5, right? So in this perspective, any vector, any point on any n-dimensional space can be considered as a vector, okay, starting from the origin. Okay, so similarly, if you consider a point on an n-dimensional space, okay, consider a point on an n-dimensional space, then that point will be characterized using n different coordinates, right? v1 v2 v3 etc up to vn. Then you can say that the vector or the line that starts from the origin and directed towards this v1 v2 etc up to vn is actually the vector v. Okay, the vector v. So I just want to convey one idea, that is, any point on an n-dimensional space can be considered as a vector. Okay, as a vector. Now the thing is, see, this is a very important fact you have to understand, that is, a line of the form ax plus by plus c equal to 0. A line of the form ax plus by plus c is equal to 0. Okay, and the vector ab, okay, and the vector ab, then the vector ab is always normal to the line ax plus by plus c equal to 0. Okay, vector ab is always normal to the line ax plus by plus c is equal to 0. Okay, so are you able to imagine how it is happening? See, suppose we have the equation, or we have the representation ax plus by plus c equal to 0, right? And for the easiness of explanation, I'm just omitting the c. I'm considering ax plus by equal to 0, right? And what is this ax plus by? It is the dot product of the vector ab and the vector xy. Okay, ab and the vector xy equal to 0. When is actually two vectors dot products are become 0? Can anyone have the idea? The vector ab and the vector xy,
Perpendicular.
yeah,
Perpendicular.
they are perpendicular, right? So from here I can say that the vector xy or the vector ab is always perpendicular towards the xy, right? Right. So if you have a line like this, 4x plus 2y equal to 0. This is the vector 4 2. Okay, this is the vector 4 2, right? Then, sorry, this is the vector xy, right? Okay, then for this vector, the vector 2 4 2 is always perpendicular, right? 4 2 is always perpendicular. Then if 4x plus 2y equal to 0 is perpendicular to vector 4 2, then all the lines, okay, all the lines which are parallel to 4x plus 2y, how we can find out all the lines parallel to ax plus by plus c equal to 0? Just change the value of c. For different values of c, you will get different lines, but they are all parallel to each other. Okay, so for 4x plus 2y equal to 0, 4x plus 2y minus 3 is parallel. 4x plus 2y plus 1 is equal to parallel. Then if a vector 4 2 is perpendicular to the line 4x plus 2y equal to 0, then it will be parallel to 4x plus 2y minus 3 equal to 0, then it will be parallel to 4x plus 2y plus 1 is equal to 0. So in general, we can say that the line ax plus by plus c equal to 0 is perpendicular to, or the vector AB is always normal to ax plus by plus c is equal to 0. Are you getting it? Are you getting the point? Do you need more clarifications on it?
Got it, sir.
Yeah. Now, the other thing, that is a function. We know what is a function, right? A function is simply a mapping from one one set of values, that is a, to another set of values b, and what is the constraint for that mapping? Every element in A should have a mapping in B, and there won't be any kind of mapping like this, because a single element in the first set will not get mapped to two elements in it. Okay, so a function is nothing but it is a mapping from one set A to another set B, where all the elements in A should have an image or a mapping in the second set. Okay, so that is what we are calling as a function, and we are clear about that, right? But what do you mean by a real function and a real valued function? What is a real function and a real valued function? It is nothing but if the inputs are taking from anywhere. Okay, if inputs are actually taken from any set S, and every output is mapped to into a real number set. Every output is mapped into a real number set, then we can say it is a real valued function. Okay, we can say that it is a real value function. Okay, like if you consider this S, if you consider this S as the set of all complex numbers, a single element in this complex number set will be of the form AI plus B, right? AI plus B. Now, the mapping from AI plus B, this is the set, okay? And the mapping F is nothing but this value. The value here is A square plus B square. So, what is happening? Here, the first set is a complex number, and the second set is a real number set, and the mapping is happening from the complex number set to real number set. Then we can say that this function f is a real valued function. Are you getting it? This function is a real valued function, and also if both the domain and the first set and second set are, both the first set and the second set are what, real numbers, then we can call it as a real function. Okay, real function. So if only the domain is real, then it is called as a real valued function, and if both the domains and codomain or the range are real, then it can be called as a real function. So how will you represent a real function? How can we represent a real function? Every real function can be represented as a curve on a two-dimensional plane. Okay, every real function can be represented as a curve on a two-dimensional space. Okay, see, this is this is a function in the form of 50x. This is a function in the form of x cube. Okay, this is a function of the form 2 raised to x, right? So for if you take any point on the x-axis which represents the domain, there will be some points on there will be some points on where y-axis which represents the line. Okay, y-axis which represents sorry, the y-axis which represents the range. Okay, so on taking the intersection of a particular input output pair, you will get a point. By taking the intersection of input out pair of another pair, by taking the input output intersection of another pair, by taking the input output intersection of another pair, and if you consider the locus of all these points, then this curve is actually represented using representing the curve y equal to f of x. Okay, is it clear? So any real function in a two-dimensional plane can be represented as a curve. Okay, so that is one important point. Then the concept of limit functions, derivatives, and all is there. Okay, and you need to think about the multivariate functions. Okay, multivariate function. So what do you mean by multivariate function? Any idea? Anyone have any idea what you mean by a multivariate function? So how we have represented our function in the previous example, it is of the form y equal to f of x, right? Y equal to f of x. And what is this y is called? This is called as a dependent variable, and x is called as a independent variable. Okay, so the dependent variable is actually depending on the independent variable. We are free to change the independent variable somehow, and according to that, with the definition of the function, the dependent variable will also change, right? But and this can be modeled in many real-time situations. Okay, see, suppose you are thinking about predicting the mark of a student object as obtained for a particular subject, maths. Okay, what will be the factor that affect the mark? Can anyone have any idea? What will be the factor that affect the parameter mark? Any guess?
Number of hours of study.
Number of?
Hours of study.
Yeah, exactly. The time, right? Yeah. So if you model this particular problem, you can say we are actually time on the x-axis, which is a independent variable, and we are considering the mark on the x-axis, sorry, y-axis, which is a dependent variable. For a particular mark, he will get time. He will get a particular mark. For another, he will get another mark. So we can model this like a curve like this, right? As the time increases, mark will get increases. At some time, at some point, what will happen? The mark become stagnant, and even after some time, maybe there is a chance of getting reduced mark, right? Okay, so here the mark is a function of, mark is a function of what? Time. But I just want to ask you, is the mark only depending on the time?
Focus.
Maybe if you can represent focus as a parameter, it will depend on focus too. Then
Knowledge about the subject.
maybe we can call it as IQ, right? Or the MQ, right? So here, what is happening? The parameter or the independent variable mark, okay, the independent variable mark, sorry, the dependent variable mark is depending on the independent variables, right? Time, focus, IQ, MQ, and all, right? So, if you consider the situation in a mathematical way, one independent variable is not at all depending on a single variable. Okay, one dependent variable is not at all depending on a an independent variable. Okay, so the influence of several variables will be there for the change of a dependent variable. So generally a multivariate function f or y can be considered as f of x1, x2, x3, etc. up to xn. Y is equal to f of x1, x2, etc. up to xn, where each of this x1, x2, etc. up to xn are independent variables, and y is the dependent variable that depends on these variables according to the definition of the function. Okay, are you getting it? What is a multivariate function? And for the ease of explanation, I am just considering a bivariate function. Okay, so what is a bivariate function? It is nothing but how many independent variables will be there?
Two.
Yeah, it is in the form of y is equal to f of x1 comma x2. Okay, so what will be the domain for this function? What will be the domain for this function? What do you mean by domain? What do you mean by domain? The domain is a set where we can choose our inputs for a function, right? So here x1 is a real number, x2 is also a real number. Okay, now how can we choose both x1 and x2?
2D plane, XY plane.
Yeah, it will be r square, right? It will be r square. So r square, how will you represent as an r square? R square is nothing but it is a two-dimensional plane represented using the one axis x and the other axis y. One axis x and another axis y. And any of this point on this plane, okay. So any of this point on this line is actually can be considered as an input to the function f. Is it clear? Right? Then for that particular pair of values, you will always get an output z. Okay, you will always get an output z or y. So for this xy value, you will get an output y. For this xy value, you will get an output y. For this xy value, you will get an output y. Right? So similarly, if you consider all these points on this domain, it will get projected in the direction of z, right? So we can completely say that our function will be always a surface, always a surface. So in a one-dimensional space, it is a what? What is that? It is a point. In a two-dimensional plane, it is a curve, and in the three-dimensional space, it is a surface. Okay, surface. And what about the n-dimensional case? What we will call it in an n-dimensional space? It is called as a hyper surface. Okay, it is called as a hyper surface. Are you getting it? Okay, so for any multivariate function, we can represent using an n-dimensional space on an n-dimensional space on an n-dimensional space. Is there any doubt? Are you clear with this? If anyone is having doubt, you can ask. Please tell me, is there any doubts in it? How to visualize a multivariate function and reconstructing the word it's like coordinate, surface, hypersurface, and all. If it is confusing, please let me know. I can explain it one more time.
So please explain it one more time.
Yeah. See, you can see my whiteboard, right?
Yes, sir. But I can see it is more like a slide sorter kind of thing. Yes, visible, sir. Visible.
Yes. Yes. So 4 is a single variate function or a univariate function, that is y is equal to f of x. Okay. How will you plot the curves? You can choose any point on this number line as x, right? And it can get mapped to some point on this line. Okay. So this is our domain and this is our range. Okay. This is our domain and this is our range. And if you choose, as per the definition of a function, if you choose any point from this line, there will be a mapping on this, right? And there will be a mapping like this. There will be a mapping like this, right?
Yes, sir.
Yeah. Now, if you organize this properly, that is, instead of taking two parallel lines, if you take this x-axis and the y-axis in a mutually perpendicular way, here also for a point here, there will be some point here, right?
Yes,
and
sir.
and you can take the intersection of these points, right? So for every point on this x, such kind of y will be there, and you can see this different intersections. Okay, and if you connect these things, you will get a curve, and this can be considered as a function y equal to f of x. Is that clear?
Yes, sir.
Yeah. So here the input to this function is only a single value, that is x, and that can be chosen from a line, right? But in the case of a multivariate function, particularly a bivariate function, the functions are in the form of y is equal to f of x1 comma x2, right?
Yes, sir.
So here the inputs to this function can be any value and it will generate an output y. Okay, so here the a can be any real number, b can be any real number, and according to those value, f will map that value to a real value, right? So how will you represent the domain for this function? I can represent this domain for this function as a plane. So here it is x1, here it is x2. Any point on this particular plane, any point on this particular plane can be an input towards this function, right? That is a point you have to make sure that you understood. Any point on this plane, any point on this plane is in the form of what? X0, Y0. It can be considered as an input towards this function f, right? And it will get mapped to some value y. That value can be again represented as a mutually perpendicular axis. Okay, so for a corresponding value of xy, you will get some value for y. For corresponding value of xy, here we have another point here, right? And for this point you will have another point here, right? So you will have a collection of such y values for different inputs from this plane. And if you locate, or if you can find out the locus of all these points mapped from all the inputs from the domain, you will always get a surface. Is the concept clear now?
Yes, sir.
Yeah. So you can imagine this concept till this three-dimensional space for a 2D function, bivariate function. But you can extend this concept to an n-dimensional space. That is, there will be n axes, there will be n axes, and that will constitute a particular input. And from that point, you can map to another point. Then in n-dimensional space, we will say we are getting a hypersurface. Okay, we are getting a hypersurface. Are you clear?
Yes, sir.
Yeah. So these are all the different bivariate functions. Okay, you can see this are simple examples of bivariate function. According to the definition of the function, the shape of the surface will change, but everything is remaining as a surface, right? That is why it is called as a bivariate function. Okay. Now, the concept of partial derivative is also very important. Okay, a partial derivative is nothing but it is a metric, or it is an idea which gives how the independent variables of a multivariate function is actually influencing the final value of a function. Okay, so I will tell you with an example. See, f of x z is equal to f of xy is a multivariate function, and the function's definition is 2x plus 3y, right? And you know the derivative of f with respect to x is what? Dou z by dou x is equal to 2, and dou z by dou y equal to 3. It is evidently clear, right? And if you locate that function for different combination of x and y values, see, for the value of x is equal to 1 and y equal to 0, what is the value of z, or what is the value of f? For x is equal to 1 and y equal to 0, what is the value of f? 2 into 1 plus 3 into 0. What is the value? Okay, fine. Yeah, 2. That is 2 into 1 plus 3 into 0, that is 2. Right? And consider the value at the point 3, 4 also. Consider the value at the point 3, 4 also. Right? So what is the value? It is 18, right? So when the function is moving from, or the function is changing from the point, the point 1 0, okay, 1 0 to the point 3 4. What is the change in the value happen? What is the change in the value happen? Can you
From
just
2
imagine?
to
It is 18 minus 2, right? It is 18 minus 2. What is 18 minus 2? It's 16, right? And what is the change happened on x? That is delta x is equal to 2, right? And what is the value change happened on y? It is the change 4. Okay. Now, just see what is happening. Here, delta x is equal to 2, delta y equal to 4. And the total change in f, that is the total change in f is what? 16, can be formulated as delta x, that is 2 into 2 plus 4 into 3. Okay, 4 into 3. That is what we are calling as 16. Okay, 16. Now, can you imagine what is the significance of partial derivative at this point? This 2 and 3 are the partial derivatives, correct? Right? The point 2, the values 2 and 3 are the partial derivatives. So, the total change happening on a function is actually the sum of the changes made by each individual variable. Sum of the change made by each individual variable, and this partial derivative will give an idea that how much that change is impacting on the output, how much that change is impacting on the output. So whenever you want to calculate the significance of the variables a1 b1 a2 b2, okay, a2 b2, how will you find out the significance of, or how much a is important towards f? You just need to calculate dou f by, right? So this quantity will give what change will happen on f, what change will happen on f if I change a unit value of g, unit value of a, right? And what is the significance of then dou f by dou b, dou f by dou b on changing dou b1, okay, b1 and dou b1 on changing a unit value of b1, how much change will happen on f? Is it clear? Is it clear?
yes, sir.
Yeah. Now, from this example, I just want to give you an idea that partial derivatives will be always useful when you want to calculate the contribution of a particular dependent variable towards the change of a function. Okay. So the importance of partial derivative is that whenever you want to calculate the contribution towards the change of a particular function by a variable, what we can do, we can consider the partial derivative. Okay, we can consider the partial derivative. Is this things clear? What we have discussed so far? Okay, so if it is clear and properly understood, we can move into the concept of neural network. Okay, see, can anyone recollect what all things we have discussed so far? Anyone? I'm just asking you to recollect. I'm not keen about getting the correct answers.
Sir, is a derivative same as gradient or is there any difference between the two?
Yes, yes, I'm going to tell that. Yeah.
Okay.
So, so with that point, we can start. That is the gradient and the derivatives. Okay, gradient and the derivatives. So a gradient or a derivative of a function, okay, a derivative of a function is nothing but it is actually giving, if suppose we have a function like this, okay. So see, if this point you consider, okay, or if you consider the lateral, so if you consider this function, okay, if you and consider these 2 points, okay, what is the rate the function is actually changing to the right side at this point P and at this point Q. At the point P, okay, at the point P, if you simply move to right, how much change in the y value you can observe? A significant change, right? If you simply move to right, you can see the change will be like this. Clear? Is it clear?
Yes, sir.
And what about this? The same unit, if you change here, what will happen? Is the is Are you getting the same change here as we observed in the previous case? Here the unit change happened on x is same, right? This change is same. But what about the change in y? It is greater in the second case, right? So idea about this change, how much change is actually happening at a particular point of a function towards its neighbors is actually called as derivative. Okay, derivative. And it is represented by dy by dx at x is equal to x0. So if you consider this as x0, so the value we are getting, the change we are getting here can be represented as dy by dx at x is equal to 0. Is it clear, ma'am?
Yes, sir. Thank you.
Yeah. Now, if you consider a multivariate function for the easiness of explanation, I'm just considering a two-dimensional function, okay, a bivariate function, okay, and this bivariate function is represented like this, okay, okay. Then at a particular point of x0, y0, you will have a value for this function, right? Okay, and when you move this x0, y0 to some x1, y1, you will have another value for this, right? Okay, another value, okay. So the change happening for this, okay, the change happening from this point towards this point will be different in terms of x-axis and y-axis, right? Are you getting it? Okay, are you getting it? See, I can demonstrate it using one more example. See, there is another tool which is called as GeoGebra. Okay, GeoGebra 3D. Okay, and If you consider this GeoGebra and I'm plotting x is equal to, sorry, y is equal, z is equal to, okay, x square plus y square, okay, x square plus y square. So if you keep this line here, okay, see from this point, from origin to this point, or if you consider this origin to 1, the point 1, the y value is changing like 1. From point 0 to 2, the y value is changing like 4, right? Is it clear? And if you make it parallel to x-axis also, if you make it parallel to x-axis also, you can observe that change, the same change. You can observe the same change. If you move from 0 to 1, if you move from 0 to 1, the change on y is 1. If you move from 0 to 2, the change on y is 4. Clear? So the same change is there. But in the case of a function like this, x minus 5 the whole square. Okay? If you see this function, if you see this function, see what is the peculiarity here? If you see, if you align the axis on y axis, if you move from 0 to 4, it is changing from 0 to 1, it is 1 unit change on y. 0 to 2, the change is 4, right? But if you align this on x axis, okay, align this on x axis, are you observing the same change? From 0 to 1, you move. What happened? How much change you can observe? The y is actually having much
4.
bigger, much bigger changes, right, than the previous one. So according to the function, I can say that, see the changes happening on a function, on a multivariate function particularly, okay, on a multivariate function like this. See, uh, if you consider a multivariate function like this, okay, at this point, at this point, the change on x, okay, the change parallel to x will be different from the change happening on the y direction. Are you getting it? And how much change is actually happening on z when you move a single value of x, that will be given as dou z by dou x, right? And how much value of change is happening on z when you move y 1 unit apart, that is represented as dou z by dou y. Is it clear? And these two values are actually constituting a vector, right? These two values are actually constituting a vector. This is actually what we are calling as gradient of a function. Are you getting it, ma'am? So in the case of a univariate function, derivative is simply giving the idea about the change happening on y with respect to x. But In the case of a multivariate function, the gradient of a function, okay, the gradient of a function represented like this, which is a collection of derivatives, which is a collection of derivatives or the partial derivatives, which will give us the idea about what will be the change happening on Z on the change happening on each of this independent variable. Is it clear?
So that means we can say that for bivariate function, what derivatives give. For multivariate function, we can say that we can focus on gradient.
Yeah, for a univariate function we can focus on derivative. For a
Hmm.
multivariate function we can focus on gradients.
Okay, okay, clear, sir. Thank you.
Sir,
Yeah,
for
so
sir, then for univariate function, there is no difference between the derivative and the gradient as such.
no, because for a univariate function the derivative is a single point, right? A
Uh-huh.
single value,
Hmm.
so that can be considered as a scalar value, right?
Yes.
Okay, but in the case, or it can be considered as a direction on a line. But in the case of a multivariate function, you will have derivatives in different directions, right? Different axes, across different axes. So that will be different for each of the axes, and together all these derivatives can be called as a gradient. The derivatives towards all the directions. The collection of derivatives towards all the axes of a function can be considered as a gradient. So as it is a collection, as I said, if you consider any point on the n-dimensional space, that is x1, x2, etc. up to xn, it can be considered as a vector. With the same idea, you can consider, as it is a collection of derivatives, then this derivative can also be this gradient can also be considered as a vector. Are you getting it, ma'am? Okay.
Yes, sir.
Yeah. Now we can move into the. This is the basic understanding you should have about the fundamental mathematics before getting into the aspect of neural network. Okay. Now we can simply move into the neural network in a very quick way. Okay. See
Excuse me,
here.
sir.
Yeah. Yeah, ma'am.
So in univariate function, it is said to be dy by dx, and in
Yeah.
multivariate function, it is said to be partial derivative, that is dou y by dou x. Why
No,
is it so? Dy and dou, why the difference?
that is only a representational difference, because the total change happening on the function is not fully contributed by the single variables, right? The total change on a function is happening as a collective sum of changes happening on each direction, right?
Okay,
So the change is partial according to each of the variable.
okay, okay,
That is why it is called as a partial derivative. And to represent it as a partial derivative, instead of using d, we are using the dou. That's it.
okay, okay. Thank you, sir.
Yeah. Okay. So, hope you are all familiar with what is a classification task, right? A classification task is nothing but you have to map a value to a particular class. Okay. So, in this example, you can see we have a classification task, okay, and we have only one feature here. We have only one feature here, and each of this data point is actually mapped to a particular class. That is, either the class can be n or the class can be p. Okay, and our need is to make a classifier or build a classifier in such a way that on getting a new point, you have to tell me that point is negative or positive, right? That is the task. And this particular data set is having only two different classes, right? That is why it is called as a binary classification problem. Okay. And see, on visualizing my data, that is -2 is negative, right? -2 is negative, 6 is positive, 7 is positive. Okay, all the positives are represented using green and all the negatives are represented using red. So on On representing this on a number line, you are able to find a hidden pattern in it, right? What is the hidden pattern here? You can observe here all the values left to 4, right? That is all the values left to 4 is negative, and all the values right to 5 is positive. That is a hidden pattern you can observe from the data. Clear? So with that hidden pattern, I am going to generalize it. What is the generalization? I am taking an interval here, that is this interval, and without any kind of bias, I am just taking the midpoint and telling that if a new point P is less than 4.5, new point 4 P is less than 4.5, it will be negative. Otherwise, it will be, else it will be positive, right? So we have n number of choices for theta, but I am just choosing an ideal value for theta, that is 4.5, and I am creating a decision rule here, that is if there is a new point P minus theta is less than 0, then it is negative, and otherwise it is positive, right? And this particular theta is actually called as a decision boundary. Okay, decision boundary. So can you just tell me, with this decision boundary, will 6.5 a negative class or a positive class? 6.5, can you tell me?
Positive.
Positive. Why? Because 6.5 minus theta, that is 6.5 minus 4.5 is equal to 2, which is a greater than value, then it is a positive class. So this is the decision rule we had, right? And this is exactly what we are calling as a model, okay, or the rule, or anything we are utilizing for making a decision can be considered as a model. Okay, and what about the class of 1.5 minus 1.5? Will it be a positive class or negative class? How will you conclude that? Minus 1.5 minus 4.5, which is equal to what? 6, right? Minus 6, which is a less than 0 value. Then we can conclude that it is a negative data point or a negative class object. Are you getting the idea clearly?
Yes, sir.
Yeah. So this is the decision point, and this is our decision root. Now consider this situation on a two-dimensional data. Two-dimensional data means instead of having one feature, here we have only one feature, right? Instead of having one feature, say we are having the data with two features, then instead of a line, the data will be scattered over a plane, right? The data will be scattered over a plane, right? And what is the peculiarity of this plane? See, you will be able to find a decision boundary as a line instead of a point in this case. And what is the general equation of this line? Ax plus by plus c equal to 0, right? So what is the peculiarity of these points? As I said in the first mathematical concept, these are the points which satisfies the inequality ax plus by plus c equal to 0, and positive points are the points which satisfies the equation ax plus by plus c equal to c greater than 0, right? So if you are able to find such a line ax plus by plus c equal to 0, on getting a new point pq, what you can conclude, if you substitute this pq on this line, that is ap plus bq plus c is less than 0, that will be a negative point, otherwise it will be a positive point. Are you getting it clear?
Yes,
Okay,
sir.
yeah. Now extend this idea into a three-dimensional surface, then what will happen? Three-dimensional space, the data will be scattered over a space, so instead of a line, we need a
Hyperplane.
plane, plane that separates two classes. Okay, plane that separates two classes. And what is the general equation of a plane? It is ax plus by plus cz plus d equal to 0, right? So just just see the pattern. As we are having two features, there will be two variables for the for the decision boundary, two constants, uh, two coefficients and a constant. As we are having three features for the data, we will have three variables for the hyperplane, three coefficients, and one constant. Then, can you imagine about the situation, or can you just extend this concept into an n-dimensional surface, n-dimensional space? What will be the peculiarity of the hyperplane there, or the decision boundary there? The decision boundary will have n variables, that is x1, x2, x3, etc. up to xn. Each will get multiplied with w1, w2, w3, etc. up to wn, and all these things will get added together, and finally there will be a constant theta, right? So this is the generalized decision boundary in an n-dimensional space, and this is what we are calling as a hyperplane. Okay, a hyperplane, a linear surface in the n-dimensional plane is actually called as a hyperplane. And this hyperplane, okay, a hyperplane can be again represented as c sigma wi xi plus theta I equal to 1 to n. Is it clear? Then how will you create the decision boundary? How will you create the decision boundary? How? See, if there are new points p1, p2, etc. up to pn, if there is it's a new point p1, p2, etc. up to pn, substitute this p1 for x1, p2 for x2, p3 for x3, and etc. up to pn for xn. And finally, if you are getting a value which is negative, then we can say that that point is a negative observation, otherwise it is a positive observation. Are you getting it? Is it clear?
Yes, sir.
Yeah. Now with this idea, we can move into the techniques of neural network. So an artificial neural network is a special kind of a machine learning algorithm which depicts the working of a human nervous system. Okay, a human nervous system. And one of the most simplest neural network is nothing but it is perceptron. Okay, it is perceptron. It is actually a depiction of our neuron. Okay, neuron, a perceptron. A perceptron is actually having a structure like this. See, it can receive n inputs, x1, x2, etc. up to n inputs, and each of these n inputs will get multiplied with a particular value, w1, w2, etc. up to wn, which is called as weights. Okay, which is called as weights, and they are all getting adding up together. That is, each of the product wi xi, w2 x2, w3 x3, etc. up to wn xn will add it together, and if it is greater than a threshold value theta, if it is greater than a threshold value theta, then the class is 1, otherwise the class is 0. So this is how a perceptron works for classification. And to change, or to we are actually putting a small modification on this equation, that is we are taking this theta to the left. And finally, what is the decision rule for this perceptron? If the inputs received on a perceptron, that is x1, x2, etc. up to xn, is getting multiplied with the corresponding weights in the perceptron minus theta is greater than 0, then the class will be 1, otherwise the class will be 0, right? So can you just relate this with the thing we have discussed earlier? Are you remembering this equation? Or can you tell me what is this equation stands for? Or what is actually represented by this equation?
A line.
It is a hyperplane, right? It is a hyperplane in an n-dimensional space. So ultimately, what we have to understand is the perceptron is a model, machine learning model, or a machine learning algorithm which will find a perceptron, we should find a hyperplane according to the data given to it. Okay, and what is the peculiarity of that hyperplane? That hyperplane should properly classify the set of all positive observations and the set of all negative observations. Okay, fine. Is that clear now? We can have more understanding of perceptron. This is a general idea of a perceptron. See how this perceptron is actually doing so. Okay, how this perceptron is actually doing so. So, what is our need? If you have a set of observations, okay, if you have a set of observations, the perceptron should be able to classify that object. That is, suppose you have a set of positive observations, you have a set of negative observations, okay, on giving this to perceptron, we should have a decision rule, okay, which is positive and negative. And if you give a new observation here, it should say whether it is positive or negative. Okay, and how it is happening? If you give a new observation, it will apply on the equation of a hyperplane, and if you're getting a negative value for that equation, then it will be a negative observation, otherwise it will be a positive observation. So what matters here? So for all these positive observations, if you substitute that on w dot x plus theta, you should get a greater than value. For all this negative observation, if you substitute this x, w dot x plus theta should be less than 0. So what makes this thing happen? It's nothing but the appropriate values of w and theta. Okay, the appropriate values of w and theta. So learning a data using perceptron algorithm is nothing but by exploring the data, you have to find the appropriate values of this w and theta, appropriate values of this w and theta, in such a way that for all the positive points, w dot x plus theta must be greater than 0, and for all the negative points, w dot x plus theta must be less than 0, right? And how you can arrive at this particular set of w and theta? It is actually happening through an algorithm called perceptron learning algorithm. And what is happening in perceptron learning algorithm? See, in perceptron learning algorithm, the input is what? A set of all data observations, okay, and some of them are positive points and some of them are negative points. So these will be labeled with 1 and these things are labeled with 0. Okay, so we have a large amount of data. Now what will happen? You have to use, or we have to choose a set of random values for w. Okay, so that random values need not to be an appropriate set of w's, right? So what will happen? To until we get the appropriate values of w, if you choose a positive observation, and on multiplying it with w, you will get a negative value. That is an error, right? That is, you are expected to have this w dot x as a positive value, but you are getting a negative value. So due to what? The incorrect values of w, right? In that case, you have to update this w as w plus x. Okay, in that case, you have to update w as w plus x. And in the case of a negative observations and you are getting a positive value on multiplying with x, that is also an error situation, right? So that is also an error situation. Again, that is due to the incorrect value of w. So you have to update the value of w as w minus x. So on repeatedly doing this, finally, you will arrive at a set of W values where if you put any positive observations with W, you will get a positive value, and if you put any negative observations with W, you will get a negative value, right? So this is exactly what happening on perceptron learning algorithm. I will show you an example how it works. Then it will be more clear to you. But the thing you have to understand here is what is the logic behind w equal to w plus x and what is the logic behind w equal to w minus x, okay, on misclassification. Okay, see, to understand that, just go through this figure. Okay, go through this figure. These are our set of positive observations, and these are our set of negative observations. As I'm choosing the random hyperplane, this is our hyperplane. Okay, this is our hyperplane. As I'm choosing the random hyperplane wt dot x, it need not to be a proper hyperplane. That is, it need not to to keep all the positive points on the right side and all the negative points on the left side. Okay, so it will be an incorrect hyperplane as it is a random thing. And as I said, if you have ax plus by plus c equal to 0, then the vector ab will be perpendicular to this line, right? Similarly, for wixi plus theta equal to 0, the vector wi will be perpendicular to that hyperplane. Okay, so this hyperplane is actually having a perpendicular vector which is called as wt. Okay, wt. Okay, and this is a wrong hyperplane now. Now think about an observation here. This observation is actually negative, but it is on the right side of the hyperplane, so it will be misclassified, right? So what we are doing is, see, we are taking this observation as x, that is the input. Okay, that is our input. Okay, that is our input. That is our input. Okay, and it is a negative one, but on multiplying we are getting a positive value, right? So what we are doing is, we are taking the negative of this vector. Okay, negative of this vector, so it will have the same that magnitude but in the opposite direction. And on adding this wt with this x, on adding this wt with this x, the resultant vector will be like this, right? This is the triangular rule. Okay, triangle rule. So wt minus t, so this is the new wt. Then as the vector move to this direction, the hyperplane will also move to this direction, right? So after this updation, the hyperplane will be like this. So now what happened? From this incorrect hyperplane, the hyperplane is now moved to a correct hyperplane. Okay, are you getting it? So now the all positive points are on the one direction, one side, and all negative points are on the next side of the hyperplane. Okay, fine. I think it is clear. Okay, now we can have this example, and after that we can have a big. Okay, see here, the components of a hyperplane is a perceptron is like, we have n inputs x1 x2 etc up to xn. There will be a set of weights w1 w2 etc up to wn, and there will be a term called theta which is called as the bias. And you know, if there is no bias, the hyperplane will get trapped in the origin. Okay, and suppose we are going to train a perceptron for depicting it as a AND gate, and we know the data, right? There are two features. So the inputs are x1 and x2, corresponding to it there are w1 and w2. There will be theta, and the inputs are 0 0 1 0 0 1 and 1 1. Okay, and the outputs are 0 0 0 and 1, you know, right? So this is a binary classification. And initially the hyperplane, this is the data point, this is 0 0, right? This is 1 0, this is 0 1, and this is 1 1. So this is the positive observation, all this is a negative observation. As we are choosing the value of w1 w2 and theta as random, the equation of the hyperplane becomes w1 x1 plus 1 x2 minus 2.5 equal to 0. And that equation is actually represented by this line. Okay, and it is evident that this line is not separating our data properly, right? Okay, not separating our data properly. So what we are doing, according to the perceptron learning algorithm, we are randomly choosing a data point, that is 0 1, and it is a negative observation. On putting that 0 1 to the equation of the hyperplane, we are also getting the negative value. Okay, fine, that is fine. But in the case of 1 1, that the data is positively classified, and on putting 1 1 on this equation, the value you are getting is minus 0.5, which is not positive, right? So that is an error case. And in that case, what we will do? We will add our input to the current weights. We will add our inputs, that is 1 1 to 1 1. So the new weights are 2 2 and minus 2.5. And on applying 0 0 on this equation, the value will be negative, and it is a negative observation. And on applying 1 0, it is a negative, and you are getting a negative observation. So finally our model converged, and that the hyperplane is having the equation 2x1 plus 2x2 minus 2.5 equal to 0. And if you visualize that line, see what is the peculiarity? That line now move from this to this, and all the negative points are on the bottom of that line, and all the positive points are on the top of that line. Okay, so what is actually happening in perceptual learning algorithm? Starting from a random set of weights, by conceiving or by consuming inputs one by one, it will look for the misclassifications. If it is misclassified, the weights are getting updated continuously until the model converge. And what do you mean by model converge? It is nothing but for all the positive points you should get a positive value, and all the negative classes you should get a negative value with the appropriate values of w and theta. Okay, and finally one more thing, see, on giving this particular input to this equation of hyperplane, you're getting an answer like 0 0, it is minus 2.5, 0 1, it is minus 0.5, 1 0, it is minus 0.5, and for 1 1, it is 1.5, right? But the desired output is actually 0 0 0 1, right? So what I am doing is, after getting this output from the perceptron, I am passing that through a function f. Here, the what is the peculiarity of f? For all value greater than 0, it will get mapped to 1. For all value less than 0, it will get mapped to 0. So the minus 2.5, minus zero point 0.5, and minus 0.1 will get mapped to 0, and 1.5 will get mapped to 1, and finally you are getting the same output of that of AND gate. Okay, same output of that of AND gate. That is the complete description. That is, we have the input x1 x2 etc up to xn. We have the weights w1 w2 etc up to wn. The bias term theta is there, and you will create the decision value at this point. Okay, the sigma, then that output is actually mapping through a function phi, which is called as an activation function. Okay, so activation function. So what is the importance of activation function in neural network? It is nothing but the output from the perceptron is transformed into desired form with the help of activation function. Okay, fine. Hope you understood. Now, after the break, we can discuss the further things. Now it is 7:35. Please join back by 7:45. Okay, fine. In between, if you have any doubts, you can ask. Is it fine?
Okay,
Can we
sir.
go for a break?
So, dear participants, we will now take a break of 10 minutes. Please return to your return by 10:45 p.m. Okay, thank you.